What's up, guys? It's Tina Wynn back here with another math lesson. Today we are doing properties of exponents. The essential question with this section of notes is how can you write general rules involving properties of exponents? Question mark.
That's beautiful, beautiful for all those of you watching. Great moment. Okay, so here we go. Listen up. All right. So we are talking about properties of exponents today. Zero exponent. It says for any non-zero number a to the 0 is 1. And I'll talk about why that is. A lot of people, they're just like, it's 1 and that's it. They don't really explain why. There are several ways that you can talk about this so that it makes sense. But the way I'm going to explain it, I think, is going to be the simplest. The only exception to that rule is when we raise 0 to the power of 0. That's really confusing to a lot of mathematicians. They don't really know what it is. So we just settle with undefined. Negative exponents. Anytime you have a negative exponent, to get rid of the negative, you're going to have to move it. Either from the numerator to the denominator, so from top to bottom, or from the denominator to the numerator. So if it's in the numerator and you want to get rid of that negative exponent, you'll take that base and exponent. The base is the large number out front, so the 4, for example, and you're going to move the entire thing to the bottom and make the exponent positive. If it's on the bottom already, if it's in the denominator already, you'll move it to the top in your numerator. The way I like to think about it is, I don't know, like if you have somebody being negative, you send them downstairs and they become positive.
Oh my God.
Or if they're negative downstairs, you bring them upstairs and they become positive. Yay. Yeah, you just flip it. Lovely. Let me stop this recording. Okay, so back here, I want to explain why when we raise a number other than 0 to the 0, it's 1. So we're just going to take a simple example and look at it. Again, there are several different ways that this works, but the simplest way to think about it is, let's say we have 2. 2 to the 0, I'm just going to list 2 to various powers. To the 0, to the first, to the second, 2 to the third. 2 to the 0 is 1, to the first is 2, 4, and 8, right? So what do we notice? When we increase our power, if we go up by 1 each time, what are we multiplying each of these numbers by? 2. If we decrease our power by 1 each time, what are we dividing each of these numbers by? 2. So 2 divided by 2 is 1. That's where that one comes from. Does that make sense? So now you know. Now you know. Okay. All right, so back up here, we're looking at evaluating each expression. The first one, what's the first one?
1.
1, yeah. Anything to the 0th power is 1 other than 0, so that's nice and simple. Now, the thing that can be confusing is b, and that is because we're dealing with parentheses. Parentheses actually do matter because we have to take into account order of operations. What do we think of when we think of order of operations? PEMDAS, yeah. And PEMDAS says that we do what before exponents? Parentheses. So we'll actually get 2 different answers based on the facts of, well, based on the placement of parentheses, whether or not we have parentheses. So this first one we have 1. The second one, if we have parentheses, this is how we'll approach it. We want to get rid of the negative exponent first, so what will I do to get rid of that?
Make it positive.
Make it positive. I'll take it from the numerator and put it on the bottom in my denominator. So this becomes 1 divided by negative 2 to the 4th. Okay? When you have parentheses, it's just 1 divided by negative 2 times negative 2 times negative 2 times negative 2. Well, negative 2 times negative 2 is what?
Positive 4.
Times negative 2?
Positive.
Negative 8 times negative 2?
Positive 16.
Positive 16. What will change if I wrote, instead of what B has, if I wrote this, without the parentheses? Well, you'd still have to bring the base and exponent to the denominator, but what would be different about my answer? It would be negative. Okay, and the reason is you have to conduct the exponents first before you take into account the negative out here. That's being multiplied, right? So you do the exponents first and then you account for the negative. The easiest way to do this so you don't get confused is whenever you don't see a parenthesis, you want to rewrite it like this. You want to go ahead and take out a -1 to account for this negative right there. And then you want to have that 2 to the -4. The reason is because it reminds you to do this first, and you get 1 over 16, and then multiply it by -1, so that changes the sign. So again, anytime you see a negative out front without parentheses, to help you remember the sign, just make that negative, turn that into a -1, that implied -1 right there. Okay, so you end up with this. Do you have questions? Yes.
Is this 6-1?
This is 6-1.
So what's the answer for B? Just B?
For B, it's just 1 over 16, because we have the parentheses.
Okay.
When we have the parentheses, we just take -2 times -2 times -2 times -2. When we don't have the parentheses, we have to do the exponents first and then take into account the negative. Yeah.
So you have to simplify.
Yes, that's a great question. If it says to simplify, this is what I want. I want the 1 over 16. If I don't say to simplify, then you could potentially leave it 2 to the 4th. Or -2 to the 4th. Okay. So, back up here it says simplify the expression. Write your answer using only positive exponents. In general, even if it doesn't say write your answer using only positive exponents, you want to write it using only positive exponents. So when you move on to algebra 2 and you see something like this, you want to simplify it so you get rid of that negative exponent on the bottom. So how could I approach this? What's the first thing you would do? Yes.
Get rid of the -3.
Yeah. Yeah, you can do that. You could also make that a 1 first. It really doesn't matter where you start here, as long as you're taking care of the exponents first. Okay? So in this case, Brooke said, I'm going to bring that y to the 3rd to the numerator so I can make it positive. And then what? What is x to the 0? Yes. And this is assuming that x cannot be 0, because if it were, then we wouldn't have a solution, right? So this is 4y to the 3rd. Yeah? Questions? Okay. Yeah. Pause. Okay, if you're watching this on video, make sure to try this, pause it, and then come back to it. I'm sorry if you hear some random sounds in the background. But, yeah. Alright, so here are the answers for the last set of problems. Do you have any questions about those? Yes. I'm going to go over number 3 anyway, just to help you guys out with the signs, because I know that that can be confusing.
Can I see number 3's problem?
Of course you can. So number 3, remember that there is a difference between -5 to the 0 power and -5 to the 0 power with parentheses. So in this case, since we don't have parentheses, what do I want to take out? Yeah, -1. So what I'm looking at is this. And then how do I make the exponent on in the denominator positive? Yeah, you move it to the numerator, so you have that, right? So you're just multiplying a bunch of things together. Well, 2 to the 4th is 4. 4 times -1 times 1, right, is -4. Questions?
Oh, can you go back to this?
Yeah. To address an issue earlier in class, just to reiterate here, if you have parentheses, so if we're taking a look at that -5 in parentheses, what I'm telling myself is to take the -5 and raise it to the 0 power. Without the parentheses, it's saying take 5, raise it to the 0 power, then multiply it by -1. Okay? All right, moving on here. Answers, and here is a math joke. So back up here, let me unfreeze this and go to the right slide. We have three different properties: the product of powers property, the quotient of powers property, and the power of power property. What does quotient have to do with? Division. Okay, so what this says is if we have two numbers that are the same base, remember that base is the bigger number, so they have to be the same base. So both 4s or both 2s or both 3s, etc. And we're multiplying them together and they both happen to be raised by exponents, then we simply just add the exponents. So 4 to the 6th times 4 to the 3rd is 4 to the 6th plus 3, which is 4 to the 9th. Now, a student asked earlier, do we have to simplify it? Do I have to tell you what 4 to the 9th is? If it says simplify, then yeah, put it in your calculator and tell me what 4 to the 9th is. If it doesn't, then you can leave it 4 to the 9th. The quotient of powers property says the opposite. If you're dividing, you do the inverse of addition, which is subtraction. So you just subtract the 6 and the 3 and you get 4 to the 3rd. The power of power property says that if you have a base raised to an exponent again, then you simply multiply the two exponents. So we have 4 to the 6th raised to the 3rd, which is 4 to the 18th, right? Simplify each expression, write your answer using only positive exponents. The first one, what will I do with the 6 and the 2?
Multiply that.
Are you combining them?
You combine them by addition, right? So you want to add them together.
You're getting a call.
And, sorry about that. If we're simplifying these expressions here, we mentioned that we're going to add those exponents. So we end up with 3 to the a. Just punch that in your calculator if you have this on a test, and you get 6,561. Okay? Now for b, what do I notice about those negative 4s? They're in parentheses. So I have to take that into account. Well, I'm dividing two exponents of the same base, so what do I do with those exponents? Subtract. Now there are two ways that you can think about this. You can just subtract them directly, and what you'll end up with is parentheses negative 4 to the what? Not to the 5th. To the negative 5th, right? Because you're subtracting.
You have another call. Your fans are calling.
Sorry about that again. For b here, I was in the middle of explaining that you can approach this two different ways. You can take 2 and subtract that from 7, or 7 from 2. You get negative 5, so negative 4 to the negative 5th power. How do I get rid of that negative 5 in the numerator? Yeah, I move it to the denominator. And when I move it to the denominator, I get 1 over 4, negative 4 to the 5th with the parentheses. And so that simplifies to 1 over 10 to 24. And then you have that negative. Because whenever you have an odd power, remember you keep the negative. So negative 4 times negative 4 times negative 4 times negative 4 times negative 4 will make that negative. Yes. If you literally have parentheses in your problem, then you take negative 4 times negative 4 times negative 4 times negative 4 times negative 4. If you do not have parentheses in the problem, take out a negative 1 first, and then do 4 times 4 times 4 times 4 times 4 times negative 1. Does that make sense?
That's pretty
Okay. Now, the other way you can think about this is you can say, I'm just going to subtract the 2, and whichever one is bigger in terms of the exponent, that's what's going to maintain that base. So here, the denominator is larger. So 7 minus 2 is 5. I'm going to keep the base in the denominator, okay? So that's another way to think about it. Okay, so C says I'm going to take z to the fourth and I'm going to raise that to the negative 3. You can approach this two ways. Multiply. That's one way. Perfect. So when you multiply the two exponents, what do you get?
Negative 12.
Yep, and then what do I do to get rid of that negative 12? Move it to the denominator. Perfect. The other way you could do this is you could move it to the denominator first. So you could say 1 over z to the 4th cubed, and then that's still 1 over z to the 4th. And then I won't go over this one because I already addressed that previously. But just one more time, if you don't have a parenthesis, you want to take a negative 1 out. If you do, then you're just taking that number and you're raising it to the power. So you're multiplying it by itself that many times.
So the first one would be negative 16, the second one would be positive 16?
Exactly. The first one would be negative 16. The second would be positive 16.
Thank you.
Okay, if you're watching this, make sure to try these problems for extra practice. Pause the video, and then I'll show you the answers. So, I'm going to reveal the answers here. 1 over 100, 1, 625. I'll go over number 7 again just to show you that the sign does make a difference. The parentheses does make a difference. 1 over y, 36, and w to the 60th. Did you get all those?
Yeah.
Okay, we'll do 7. Let's do 7. So, I don't have parentheses. So if I don't have parentheses, what do I take out?
Take out the negative.
A negative 1. Right, so that's exactly what I'm going to do first. I'm going to take out a negative 1 so I don't mess up the sign at the end. So that leaves me with 5 to the 8. And then I'm going to do the same thing in my denominator. I'm going to take out that negative 1. That leaves me with 5 to the 4th. Well, I have to do exponents before I do division, right? So 5 to the 8th divided by 5 to the 4th, what happens to those exponents? You subtract them. Right, and so you end up with negative 1, and then you have 5 to the 4th on top, that's the larger one. And then you still have that negative 1 on the bottom. Well, what's a negative divided by a negative? A positive. So you just get 5 to the 4th, which is 625. Does that make more sense?
Yes.
Okay, good. So the last slide here is the updated homework. This homework is for 2 days. So for today and tomorrow, you should be able to get through 35 fine. If you want to move on, you can. You don't have to. I'm going to teach the rest tomorrow. So this is for today and tomorrow, which is right there. Yes.
Can I take pictures?
Yeah.